Couple of minutes. One is anyone interested in the Internet of Things? I think Preston is having a session tonight at 6 o'clock with the Arduinos and Raspberry Pis. The second regards our class. So how many of you have the test? One of the things that you have to be aware of when developing applications, or even one of the sort of the defining aspects of our field is if you're in accounting or marketing, what you do at work is fairly the types of jobs correlate fairly straightforwardly to what you do. There are not 10 different options. In MIS, obviously there are. So one of the things that you'll find is, regardless of what you do, what subfield of MIS you end up in, whether it's design, development, analysis, networking, what do you think is core to each one of these? What do you need to do? It probably applies even in marketing. And what's the hint is that I'm right there, right? What do you need to do? Can you hand something to, whether it's a client, customer, end user, in any form, before you hand something over to them, what do you need to do? Yeah. You have to test it in some form. It may not exactly take the form of a program or a test like this, but there is some form of testing. You have to test and validate whether it's working or not. And in this case, what did we have to do, or what did we not do? We had the illusion this was working, right? The logic is the logic working as is? If I were to run this, does it work? Okay, so where did it fail? Initially it seemed to be working, but now I've sort of embedded all the tests inside. Basically, there are 1, 2, 3, 4 tests. You could change it to indicate, so you can literally call a test by saying input term is 1, expected is 0, test, right? And so right now, if a test fails, how do you know which part of this particular test failed? What tells you that? Yeah?
You have to click on the test and it will come with the description.
Okay, the description, and this is why what gives you the description? Expected 1, actual 0, if it was just that, it's somewhat okay, but you probably want to make it a little more descriptive by having this text in there. Okay, now what was it that we didn't test initially that is now failing? Somebody other than Ashley? Yeah, Chris.
So we fixed it. So originally, now that it was indexed was smaller than the input term. But let me ask the bigger picture. Always, I want you to relate it. Don't go into the code. You're talking to end users. The issue is think big picture and then go. You never want to talk in code because then it doesn't make sense.
So tell me what was it that we did or did not do? What was it at the end that made our test fail? Or why is it that my test, at least my test, is failing? This was the very last thing we did towards the end of last class.
Now, when we're trying to find the second input term, it's not giving us the correct result. It's giving us a 0 instead of a 1.
Okay. So the expected value was 1. We are getting 0. Yeah. So the lesson from this, what lesson do you learn from this? It seemed we started our testing with the very first term, and then we said, okay, let's go to something higher, like the 6th term, and then we said, okay, let's go for something the 10th term. So what's the lesson for us in testing?
Just because a few of the results are right doesn't mean that it's going to work every single time. Okay,
and so how do you choose values to test?
Well, you could pick ones based off of the numbers.
TJ, what did you tell you? You have to be with your group and don't come in late.
I emailed you.
No, you. Okay. Anyways, don't just walk in. Always try to be. You have this test. Okay, go back.
So I guess in like this case, you can go through select the test points and debugging, and you could based off the numbers.
But how do you choose that? Let me ask somebody who's done a reasonable amount of reasoning. Let me come here. Trista, how do you reason through what values to choose for testing?
Well, I would test the first couple numbers just to make sure that it's going like in the correct sequence, and then after that you can choose. I would choose a higher number to make sure that it continues working throughout the rest of the sequence.
When you say couple numbers, so on what basis do you choose it? Like, for example, we started with 1 because that's what we thought was the lowest, and then we went with higher values. Now, we are failing with this term. If we had thought through this process, we should have thought of this term. Why?
Index is equal to 2. So
there's a very fundamental reason. Eric? No? How does the Fibonacci sequence work?
It builds off the numbers.
2 seed numbers, right? So which means that so what we have to think of are points of failure, right? What are the likely points of failure? The 2 seed numbers are our first 2 numbers. So we need to make sure that the seed numbers are correct. So essentially, our point of failure, potential point of failure, is not just this first term alone, but the second term as well. So these 2 are crucial to start off our process, right? If we don't get those 2 correct, then potentially there are problems going down the line. So what you want to think of are, like in the Fibonacci sequence, as Eric pointed out, is just that we build on the seed values, the first 2 values. So one thing I would think of is those are my first 2 points of failure. So I want to check for those 2 inputs, do their work. And then I want to go to the boundaries. So in this case, it's basically, it goes on. There is no end point at the higher level, so I give at least a couple of values that are much higher. Okay, Megan, did you get it to work? Did you change the logic to get this test to work?
I got mine to work.
Okay.
But then Krista just tried it out on hers, and hers threw an error, so I don't know if I'm right.
Okay. What is that? What did you do to change it to work?
And we had the less than or equal sign, and we removed the equal sign. I thought maybe it was because we had int I equals 2, so I just took it back 1 to 1. And mine running it.
Okay. What's the logic? What are we saying now?
Well, now we were starting at 1, so it still doesn't bring that down, right?
Well, because
Starting at 2 because you already have that 1, right?
well, we are starting this loop at. We are saying a starting value for the loop. The index is 1. If you are going to bring it down to 1, we had changed this from less than or equal to less than the input term. Okay, so the input term. So the reason through this, why did we change it from less than or equal to less than?
Because it was still running. It was running an extra time when it should have been because it was trying to set the number equal.
So it was saying, so when we started with, so let's start with the simplest case. If we start at an index of 1, the input term is 1, okay. If the input term is 1 and the index is 1, what happens? Do we get into the loop? Will we get into the loop? If the input term is 1, so we are starting with 1. Okay. So let's just go through this. Input term is 1, and what is the Fibonacci number that's going to get returned? So input term is 1. Do we get into this loop? Yes. So if we don't get into the loop, and that was our objective for input term 1, right? We don't want to get into the loop. If we get into the loop, what happens? It's going to add these two, which will give us an incorrect result. And so for the first term, we said we didn't want to get into it. And what would be the Fibonacci result that gets returned? It will be 0 as long as we don't get into the loop. This doesn't get reset, so this is 0. Okay. Now if I move this over, okay. What about the second input term? What happens if I have the input term as 2? Will I get into the loop? Because 1 is less than 2, and what happens?
You would add 1, so it would be getting 1%. Okay,
we'll get 1, which is what we want our second term to be. So let's move to the third term and see if whatever we are doing is going to work or not. So input term is 3, and index starts at 1. So when we run this, what happens? So 1 is less than 3. We're going to come into this. Fibonacci result is what? We're starting at 3, so index is 1 when we first get into the loop. So this result ends up being what? The first time through the loop. Okay, this is 1, and this now goes to what's it? 1. Okay, and this goes to. Okay, so you have 1, 1, 1 for all 3 variables with index 1. The index gets incremented to 2. So what happens then? The result goes to You said everything was 1, so it'll be 2, and then this goes to 1, 2. So result 2, number 1, 1, number 2, 2. And the input, so the next time through, the index is 3. What happens? Okay, so the result is now at what value?
3.
Is it at 3? It's at 2, right? It's not going to get in, but but the issue is this correct? We need it to be 1. So this logic is not working, which is so the issue was once we move this from 2 to 1, it gives us the correct value for the first 2 terms, but it starts to break down for the third term. So obviously that logic doesn't work. So did anyone figure out anything that works? Yeah.
I just left the remove and the index the same, like at 2. And then threw in an if statement that if the input term was 1, and just return 0.
Where did you put the if statement?
Outside of scope, like above it.
Okay.
After the initializing the variable.
Okay. I actually did. What did you do? You had. Okay. Okay. So did anyone get this to work without using an if statement? Logan, did you use an if statement?
Yeah.
Okay. Is the test running now? Okay, so Eric, your test, I'm assuming, is running. Who else is getting it wrong? None of the others? So Eric has given the clue to us, right? He said he used the if statement outside. You don't want to put it inside the loop, put it outside. I think Ashley and Eric, yours are working, I'm assuming, the test. Okay, so I want the others to put in an if statement and do a test well so that your tests run. If you want to make it sort of symmetric, you might want to do it for both. It works, but you might want to include it for both the first as well as the second. It's just otherwise, if you read it, you may not understand why. I think at the bottom there's the actual error itself. What's it saying? Okay, just say no, and then let's go to that and see if I so you might have there's either no, the thing is there is either an extra or a missing 30 grades.
Oh, okay.
Well, that's right. See, the thing is, you don't want to have to. I want you to get to the point where you can just reason through it and write it. Okay, yeah, so if it's 1, yeah, something like that, yeah. And if you want to make it really efficient, you put, yeah, this is clean enough, I think. Yeah, the thing is sometimes if somebody were to read it later,
Why that is
exactly, yeah, and so we are basically saying these are the few seed elements of the when was the fast company, was it yesterday, the one where they were having this
Yeah, it was yesterday.
yesterday? If you said you were interested,
Yeah, I have an interview today.
you were also in.
Yeah.
Is the minute yeah? Okay. You're well, okay, the simplest thing is instead of just saying return, you just have, you are using Fibonacci results to return. So what can you do? Yeah. What are the terms that are giving us the problems? Yeah, you have to do it yourself. Let her do it.
Should I know what the results should be?
No, let her do it. Otherwise, she's not going to learn. You come up here and explain. Come on up here. Explain the program. One of the things I'll get very upset is if you tell somebody what to do.
Well, she asked if and it was 0, but should the result, what should it be returning?
Yeah, that's an answer, right? Okay, come up. Tell me what is your question.
I just asked if the input term was 1, what would the result be? Because I'm putting it in my code, it has like me using the code, it's just a question about what our assignment is.
That's the question about the code, the logic. Again, ultimately, it's not about getting something to work. It's about understanding. So explain to me, what are we trying to fix here? What is our problem for us?
The problem is that we're trying to put it so that the first result is always going to, or the second result is going to return 0. And the second input term is always going to return.
Okay, so where is it that the loop, what we have in our loop here, what does it take care of?
It takes care of the second input. It's going to take care of the second input term.
Does it take care of the second input term?
Well, since the index equals 2.
When the index is 2, is it working? So the problem conceptually, logically is because the Fibonacci sequence has these starting terms, the first 2 terms. So anything after that, the loop takes care of. So what we are trying to fix or address are the first 2 terms. Okay, so that's, again, I want you to think through the logic of it, because ultimately what companies are interested in they're not going to just like Fibonacci sequence, what you can always look up, get a code snippet and put it in. But what are they looking to hire you for? Well, logic, to be able to solve their problems, like if you go to Plus Consulting like Logan, or
unless give us yeah, they are looking at problem solving. So ultimately, I want you to think, so given a problem, how do I solve it? And which ultimately comes down to isolating it to, so this logic solves a part of the problem, so what is it that is unsolved? And that's why you have those if statements. And I want Megan to figure it out as well. If she doesn't figure it out, if you tell the answer, then you're doing her a disservice. So if at all, I'm fine with you working with groups of our in pairs, but whenever there's a question, you have to discuss to develop to others understand. Okay, so who else is now figured it out? Okay. Okay, so one of the things I told Eric was to just make it clear that the issue is with the fixed terms. It'll work here, but if somebody sees the way are you just putting, you probably want it for both the first and the second term. If you have it working, so do you have it? Well, the cleaner approach is to discuss that is something it shouldn't work, and if you don't tell me why.
I've just done it for just one particular sort and see what should be the first one.
So your condition is you're saying what's the symbol indicating?
Yes, sure.
No. What does that symbol mean? It's or. So what are you saying if you have to translate it to English? What are you saying?
It's input 0. Then it's 2 if it's 1.
Now, what you're saying is input term is 0 or input term 1. If you want to return 1, is that logically correct? So you cannot say if it is 0 or 1, return 1. So you have to revise the logic. What I'm asking for is fairly simple, the if statement, well, if you want to before the loop, because if you do this, again, the problem point is not the term being true or greater. We are trying to handle the first two terms, input term being 1 or input term being 2, because those are the seed values, and those are the ones that are really the problem values. So one of the things is to so basically we are checking to see if whatever the user provides us is 0, if it's 1, and we are wanting to if it is 1, what are we wanting to do? Yeah. Okay, we want to give the result 0. So some of you are trying to say return 0, but the cleaner approach is to say I want to assign 0 to the result. I'd like to have this. Okay. And you can have a separate if statement, but you can also, for small programs, this is not going to make much of a difference. So I could just say if the second problematic term is 2, and I could say, well, and actually the only one, as Eric was pointing out, and I think TJ also did it, the place where you get an error is for this. But if you later on, if you come in as somebody who's looking at the program to understand it, you want to say, well, if you just see input term 2 alone has an if statement, it wouldn't make sense. It basically says these 2 are the seed values, so I'm going to sort of pre-assign it, and then if I come into the loop, it takes care of every value beyond that. So what do I say for this? Okay. And I think because I moved everything over, it should auto-format. But anyways, so the issue is, how can I make this a little more efficient? Here, as I said, it's not as significant or important. But if you are dealing with a larger program, it might make it more efficient if you did something here. You would change the if statements, right? So you can say else if. So by using the else, when does it come to this point? Yeah. Yeah, and you could also consider putting another else and nesting this entire loop inside of it if you don't want it to come here unless it's not one of these values. So you could do that as well. But as I said again, with very few values and a simple program, it doesn't really affect it. But if you are using databases, reading from databases, then you want to. These small things make a difference. Also, if you are dealing with thousands of rows of data. So one of the things gradually as we go along, I'll ask you to think of these efficiency considerations, because sometimes when you are a user, the response time matters, because if you don't get back a response within some microseconds or milliseconds, you tend to not use the application. Okay, so now let's test this and see if our test works. Okay, so this should pass. So I'm assuming that you're fine with this logic. Now, let's say we don't just want one single term. We want the entire sequence. So let's say I gave the where's my test? If I say, well, input term is 6. I don't necessarily just want back 5, but I want all the preceding numbers as well. So how do I deal with that? Yeah.
Did you say another variable inside the for loop and I guess inside the statement?
You could do that, but one other approach would be, so this, is reliably providing you a single Fibonacci number for a given term. So let's say, so we know this, and we have tested it. Now, if we use the object-oriented approach, what would we think of doing?
You could build an array, and then each time the loop iterates, add the Fibonacci result to the array.
Okay, so the issue is, do we build the array into this method, or what would you recommend?
So I would put it in the method because that's really all it's doing. It's just returning a series of Fibonacci numbers. Okay,
so there are two approaches now. One is to just add the array or whatever the collection object is into this method. The other approach is to say, well, this gives me an individual Fibonacci number, but I will use another method which uses this method or calls this method. So which gives me, so this gives me one number at a time. Now, if I want an entire sequence of numbers, then I have another method, but that method is not going to do all the work. It's going to use this method as well. Okay. So by doing that, you accomplish two things. What are the two things? One is you have the option of getting just a single number instead of a sequence, right? And the second is you have something that is fully tested now that you can use to calculate a second option, which is a set of values. Okay, so that would be how you would think if you're thinking purely in object-oriented way. So okay. So I'm going to call this, instead of find Fibonacci number, I'm going to call it find sequence or series. Okay. What I would like for you to do is to give the full signature. What's the full signature here? What's missing?
We need the return data type and a parameter.
Yeah, the parameter and the return data type. So think of what you will enter into these two. Obviously, I won't be able to come around every time, but I'll give you a minute or two to think about it, and then I want you to try it out so that before I start typing, I want you to do it. If you look up here every time for you to start typing in, that means that you've not understood it, and it will become more and more problematic as you progress. So you have to try it out, and then look up and see if that's what you did. If it's different, try to understand why or what you did. Okay, so let me ask somebody, this is the easy question. Kosh, what is the parameter here? It's going to be basically the same thing. The user is giving an input term, so input term, And this is the second question is the return type. So how many of you figured out a return type? Okay, anyone other? Okay, Liv, what was the return type?
An array,
Okay, you could do this. Did anyone do anything different from this? Yes, TJ. You had a string. So you wanted to send back a string. Okay, the issue is though I would prefer in this case an int because an integer array, because you don't know how the user would then, or whichever calls this, if you, the string is sort of less flexible in that you sort of converted it into something that cannot be manipulated. Well, if somebody wants it back to look at it, then an integer. But for the array, what are the other options? In 352, did you look at other options for arrays? What were the other options? Well, you can set up an array like this, but is there any other way to do it?
Do an array of arrays, and you can set up another set of brackets?
Well, in this case, do we need it?
No.
Okay, so...
You can do like two-dimensional or jagged or...
Yeah, we could, but in this case, we don't quite need it. But what I was asking is this goes back, this form of the array goes back nearly 25 years to when C was first created. But since then, this is not quite the object-oriented way of creating arrays. Yeah.
Is it an array list?
Okay, you can use an array list. And how do you array list? So it's not recognizing it. So if you want it to be an array list, you have to. Does anyone know why it's not recognizing it? Yeah, there is. It's coming from the system.collection. So you have to have a using statement. So if you have a data type like this, which is more object-oriented, what would you have to do? What's the return type? So one option, this will work, but this is an older non-object-oriented option. So Eric just pointed out, array list is an option, so what's the return type?
You could do array list as the return type.
Okay.
Or couldn't you also do just an object?
No, you don't want to make it a generic, so you're saying, okay, just call it object here, like this. It might work, but it's not a reliable way of working because you are returning a specific data type. Object means it can be any object at all. So we want to make it this if you're going to use an array list. So that's the second option, using an array list, which is a significantly better option to this. But there is a third option that's been introduced over the past 5-6 years, and several languages are introducing it. I will discuss it more in length as we go along. Has anyone seen this notation? List of integers. Okay, this is, yeah.
Is that similar to the linked list? Is that the C# version of the linked list?
No, it's called the generics option. So you have a list of, and within, so the list clause does a generic set of, so it can sort, you can search inside it, you can add to it, and so on. And then you're saying, I now specify whatever is inside this list is of this particular data type. So you can put int, double, or you can later on create your own list of students, let's say, and you can have a list of students and so on. But in this case, it's a list of int. Yeah.
You can handle generic.
Yes. Yeah. So this would be, so you have three different options, and what most developers and Microsoft would recommend, not only Microsoft but Java and different environments have this as well, would be, so this is called the generics option. So generics being that this is generic to any data type, so you can plug in any data type into this within the angled brackets. Okay, so if you're returning this generic list, what do you think I have to do here for the return type? Yeah, yeah, just this. So that's pretty much it. And I have to declare a variable of this type. So I'll say list of, so what's a meaningful name here? Okay, good. And whenever, since we are in the object-oriented world, whenever we create an object from a class, we have to create an instance of it. Okay, so, and at the very end, why is it complaining here? How many of you can tell me why it's complaining? Megan? Okay, I promised to return a list of integers. Right? So what should my return statement read? Somebody other than Megan? Yeah, Logan? Okay, return. Should I say list of int like this? What would I read? A TJ? Yeah, this is a variable of this type. So when I say I'm returning this type, it's basically I'm promising to return a variable that is of that particular data type. So it will be return okay. Now what do I have in between? Yeah. Yeah, between setting this up and returning. How do I accumulate all the? Okay, I want to call it. So how do I call this? Okay. So I'm using that. Say find Fibonacci number. I have to send in some parameter, and what's the parameter I send in? Yeah, the input time. Okay, so this will, so if I start, let's say if my input term is 6, then this will give me the value. I think it's in the Fibonacci number is 5. But what do I want? I want all of the numbers. Yeah. Yeah. Okay. How many of you can figure out how I can get? So I'll tell you what allows me to keep adding to this list. And one of the nice things about I'll just put it here. So these two pieces. One is, this is how I call the method that will find me the Fibonacci number for a particular term. And the second is, how do I add to a list is as simple as the add method. So this is how you have your object orientation set up, there's all of these methods that come, and these are all pre-built methods that come with the list option or the list generator. Okay. So what do I add in here? It's going to be a list of terms, and you can see from the IntelliSense what is the parameter that add takes in. The item has to be of integer data type, okay, because we specified this list is a list of integers. So what you need to figure out is how do you use these two statements. Try it out, and also as you're doing this, how do we validate whether this works or not? Go to your test and go into calculator test, and we'll add in our test. So what I'll have you do is create a test method inside. So this is my end of okay, so make sure that one of the things that you can run into trouble is the curly braces. This is end of class, end of namespace. Okay, so just below that, you need to create. So what I'll do is, to make it simple, I'm just going to copy paste where it says test method and this find Fibonacci number test. I'll just come under this where it's ended, and I'll put this in. Obviously I can't call it find Fibonacci number. This is going to be find Fibonacci sequence test. Okay, and this will be the so what I need to do now is set up my test, and I'll have you think through how you set up the tests as well. So you always want your method and your test to sort of be there. So in fact, if you use Scrum, the recommendation is you first write the test and then write the method that actually provides the logic for the test. Okay. So just to see that you're understanding this, I want you to write your test. One of the things you'll find is, and I'll have you write it and then we will discuss it, but first I want you to go through. So one is to write at least, well, start with, let's see, the same set of terms. Start with 1, then 2, and then maybe go up to 6. And then figure out what logic you need to have inside here, now that you know how to call the method and how you need to add the terms. So try to create this method inside the logic inside the find Fibonacci sequence. I'll give you about 5 minutes to try to figure that out, and then we'll discuss it. Well, in the test clause, you're just calling it, but here you need the logic to accumulate. So previously this got 1 number, now you need to get all the numbers up to that number. No, it's just going to be, it's just going to be a list of integers, so it's not a string. So it will be like, if you want to visualize it, it's like a list of You can almost think of it like this, and if you're having 4 terms, it's going to return. So there's nothing, it's sort of, it's an object which has 4 compartments, each of which could contribute. So you don't have to think of how to separate them with tabs or something.
So when we're talking about looking at those projects, what should be, should it just be all the numbers in a row, no places and numbers?
So I want to see how you set it up. It's not going to, so it's not coming back as a string. What's it coming back as? A list. So you just compare 2 lists. What I want you to focus on first is, let's see if you can figure out the logic here in the method, and then once you've figured that out, at least a starting point, you can move to the test and start putting in the test. Going very close, actually. What you have in there, you would have there. But you're right, that's just one small piece. The thing you would need, and I see PJ has it, and Eric and
What the test or
no, this is not the other logic data. Okay, then just adding and you vary and set the test, so you have your logic inside the main method to calculate it for this is just the other one. You have only the following. And it, and what did you add to? Okay. Calling it and adding it. If it will work for one term, that will happen. Some of you are on the right track. You need to think of like TJ, Eric have thought about it. You need a loop for this. The other side is when you're testing, you have to ask yourself, what are you testing? What is being tested? So when you call this method here, what are you expecting back from here? A list. So when we do the test, we are not just testing integers, but we're going to test. We are testing or comparing
two lists, right? One expected list and an actual list. And so whenever you are testing, these are lists are called lists, arrays, array lists. These are all called collection objects or collections. So instead of using an assert, you would have to use a collection assert. So you can say collection assert are equal, and obviously you have an expected and an actual. Okay. So these are the hints that obviously you don't, but other parts are all logical. So whatever is logical, I want you to figure out. Whatever is, you need to have some help, I'm going to provide you that. But so here, think of a loop, and here you need to think of getting two lists to compare the expected with the actual. Okay. So just create it as a new list. So it will be okay. Whenever you're creating lists, it has to be a new object. So when we say expected list of integers, expected whatever list. And if you have this not being recognized, you have to reference the system.collections.generic. But the result, you don't want to listen to the result. Then you get writing okay, the input term, but the input term is only one value. So I just
just like it.
Yeah,
That's what I was thinking.
but you have to have it just as a local variable. But you're on the right track. So. Here it's only the logic you are calling but whatever you're doing has to be inside of it except for the return state. Yes. We don't want to repeat the logic. So, this is just making use of the other method, so you're not wanting to repeat the logic.
Yeah.
One of the things is you have to send in a parameter for this method to do its work, but you have to figure out whether it's input term. I just said there is some parameter which is an integer that you need to send in, but if you just send input term in, there's always only one value that goes in. So you have to figure out what's this parameter you send to the other. So I see a few of you have set up the loop. So let's see how do you set up this loop. Int, what do you call it? Rather than this usually is index. You're starting from, where do you want to start from? What would be the starting? Krista, what would be the starting of this index? Usually you think of 0, but the Fibonacci sequence, it's starting with 1, right? So we want to start it at 1. And where do we want to stop? Let's see, Kash, did you think of it? Up to what, like you can think through it logically. So what are we trying to build? We are trying to build the Fibonacci sequence. Up to, well, if we give it as 6, then it would be, so if I said something like this, index, we want to go up to 6, so do I set it less than 6? Less than or equal to 6, we want to go up to 6. Okay, so it's not just less than, but less, so that will take us 1, 2, 3, 4, 5, 6. Okay, somebody else, maybe Bolaji, Kash has the logic somewhat correct. What's incorrect about this? That should be obvious to you. If I set it up this way, how many of you see the problem here? What's that? No, the logic here, less than or equal to, is correct, but there's something else that is incorrect here. Okay, I'm hoping most of you see it. It's quite obvious. Let me ask TJ.
Instead of it at 6, the amount of times it's going to run.
Yeah.
You want it to produce what I use an inputs are.
Yeah. Yeah, so one of the things you have to guard against is hard coding values. If you hard code a value, you only do it that number of times. So you don't give user flexibility, so instead it should be up to whatever the user gives, so that's input term. And then, of course, you increment the index. And I said pretty much everything occurs inside the loop, the logic. Well, inside the loop, and where you go and ask, so you can say, well, I'm going to have the other method do its work for me, and then whatever value that is provided is what I add to the sequence, and finally I will return that sequence. So how many of you have figured out, well, this step? I think I saw TJ was very close to, well, he had this, I think. So these two obviously are interrelated. You could, if you are really, you could even do it in one single step. If you are really comfortable with object orientation and methods. So, Eric, did you figure out doing it in just one step, or did you have it? Yeah. Okay. Are you running your steps now?
Yes. If you know the first time, I think I can see it.
Okay.
I think I figured out this.
You could do it that way, or you could just add in. Yeah, this probably should work as well. The other is just using a series of add methods. Accepting it or just doing an error. It's going across different representations. This is probably the easier one. The other is to just say whatever expected dot add 0, add 1, add. But this is a little easier because you can just put it all in. Okay, so you're done. Since we are running out of time, I want you to think through this and have it functioning. The other thing I want, how many of you have, this is again for something that helps your logical thinking and working on problems. How many of you have heard of recursion? Have you applied it to any problem? Okay. We can do this Fibonacci sequence using the recursive process, especially finding this. So one thing I would like you to do is obviously get this test working. The other is to look at another method called find Fibonacci number by recursion. So for those of you who are able to figure this out and have the test running, like Eric, for example, try this out by recursion. It's again a way of expanding your way of thinking. We'll discuss it next class, and then next week we'll be moving into group projects. So you have to come in with your project. I think you were saying you'll give a new project proposal. You have decided to work with.
We're running a new one. I can email it.
Okay, that's okay. Can do that. Okay, so before you come to class, please work on this. Even if you don't get it working fully, that's fine. I want to see you having tried it out. Okay. And if you have questions, come with those questions to class. Okay, that's about it. I'll see you on Tuesday.
Uh,